recording off when I'm done teaching when we go to do the group activity, but I'll be recording for the lesson part of today's class. It is, like I said, not a very long lesson, but it is important. So if you didn't quite understand what was going on in the bell work, that's okay. I'm going to explain everything from scratch, as always. And then, like I said, the activity today, which you are going to do in groups, is going to help further your understanding of what's going on. So what we're going to be doing today, next in line for the bathroom is Michelle. What we're going to be doing today is learning how to interpret Lewis structures to figure out what is the shape of molecules and what is the bond angle around the central atom in molecules. So I'm going to go ahead and pull up the lesson notes now. Go ahead and write Unit 3, Lesson 5. Shapes of molecules and bond angles. I do want to remind everyone once again that this is the class that I am recording in today. So I'm recording the lesson right now. And I will stop recording once we switch to the group activity. And I'll be posting, as always, the lesson after school. So that if you need to rewatch or take additional notes, you can do so. So Unit 3, Lesson 5, we're going over how to interpret what the shape of a molecule is and what the bond angle is. So when you think of shape, what do you think of? Circle, triangle, square, ball, right? Sphere. So when we look at molecules, they're not all flat. They have dimension to them. They fill an amount of space. And so some molecules lie on 2 dimensions, but some molecules actually lie on 3 dimensions. 3 dimensions. And so what you're going to be doing today, these are the little molecules you'll be building. They'll look like this. What we're going to be doing today is we're going to learn how molecules are shaped. And so in this part of the class, the previous class, you will only have to predict shapes around 1 or 2 central elements. But in more advanced topics, you could get molecules like this. Anybody know what this is? Have you ever seen anything like this? They're atoms. Ever seen anything like this in biology? Yeah. When you study macromolecules? Nucleic acids. This isn't a nucleic acid, but that's an example of a macromolecule. It's a carbohydrate. That's correct. This is a carbohydrate. And it's actually, what's being shown in here is just a bunch of carbon atoms, oxygen, and hydrogen with the correct bond angle, and the shapes of the molecule. And the shape of the molecule tells you its function, how it behaves. This specific molecule is actually named fructose. So it's a type of sugar that's in fruit, fructose. But anyway, so when you're building molecules today, you'll be building much simpler molecules than this. You'll be building with only 1 or 2 central atoms. However, you'll be able to interpret large molecules to see what their overall shapes are and why their shapes are the way they are. And so this lesson, that's why I said it's not very long, but it is a very important lesson for any advanced course that you may study. All right, so hopefully you've written the title down. Unit 3, Lesson 5, Shapes of Molecules and Bond Angles. First things first. Unfortunately, the way we have been drawing, and so you're going to want to write just what I write the box around, which is the bolded underlined part. The way we have been drawing Lewis structures is sometimes not the best. It's a very simplistic method of drawing how molecules are, but we are not, or we have not yet, seen how molecules are actually organized. We don't know what their 3-dimensional shapes are. When I taught you, and I have to do it this way on purpose, when I taught you how to draw Lewis structures and you had CH4, we said put the carbon in the middle, imagine the carbon has 4 sides, and you put a hydrogen atom around. each of the four sides, right? But when we draw the molecule in this manner, it leads us to an idea that's actually an incorrect idea. What do you think, if you were just to look at this, what is the angle between these two hydrogen atoms? What do you think that is? And yeah, math, right? It's a right angle, right? How we've drawn it makes it look like the hydrogens are 90 degrees apart from each other. That's what you would think, but that's actually wrong. And so what this statement up here says is that the way we've been writing Lewis structures, and that's the way you have to initially learn how to write them, doesn't accurately show the shape of the molecule. This is CH4, and you'll be building molecules like this later, and you can see that the hydrogens are actually not 90 degrees apart. It's a little bit different, and you'll see that on the next slide. So what we're going to learn is the theory that explains what the actual angles around are and why they are what they are. All right, so I'm giving about 20 more seconds here. You only had to write the part in the box, and then we're going to continue. All right, so we're going to go ahead and continue. So before I get to the name of the theory, this is the same thing that I just said. It turns out that experimentally we know that the hydrogens are actually not 90 degrees apart from each other. The way we drew the Lewis structure was very simple, but it was actually not quite right. They're 109.5 degrees apart from each other, which is different than 90. And so now we have to figure out, well, why is that? What could be the reasons that the angles would think that it would be 90, but it's actually 109. And so the reason why, and go ahead and write down, this is the major theory you need to know for this lesson, is called the VSEPR theory, which I'm going to write down the acronym shortly. German.
Where's oh.
So VSEPR. You should write down what that stands for. It was in the tutorial, but I didn't ask you to write down notes in the tutorial, so you should write it down now. Valence, shell, electron, pair, repulsion. VSEPR stands for valence shell electron pair repulsion. And so the official definition of what it is, what the theory is that it states that electron pairs repel each other, and because they do, this causes a molecule to adjust, the atoms move around the central atom to adjust so that the pairs of electrons stay as far apart from each other as possible. And so what I'm going to do is write a simpler version of that here. All the valence shell electron pair repulsion theory really states is that electron pairs repel other electron pairs. Which is actually something we covered in Unit 1 in a way. If you recall back in the beginning of this class, I said there were a few concepts that if you knew them, it'll take you through most of the class because a lot of our ideas build off of the same foundations. If I know, what is the charge of electrons? Negative or positive? And the charge of other electrons would also be negative. So if I have electrons and I have other groups of electrons, would those groups of electrons want to get close to each other? Or would they want to get as far apart away from each other as possible? Which do you think is true? Far, right? So the idea is that because electrons repel each other, the atoms around a center element will move as far apart away from each other as they possibly can to minimize that propulsion. And so you'll want to write down the extra part that I added, which is the acronym, what does it stand for, and then a simpler version of what the theory really states. And so going back to CH4, apparently 90 degrees wasn't as far apart as those hydrogen atoms could get from each other. They could get 109.5 degrees apart from each other, but half. So the idea is, when we have drawn all of our Lewis structures that we have drawn them all in 2 dimensions, right? Like, just 2 dimensions, flat. Everything we've drawn has been flat. But CH4 actually exists in 3 dimensions. So because there's a 3rd dimension, that means that the hydrogen atoms can actually get farther apart from each other than what we've suggested here. So that is an important thing that you need to be aware of. All right, so I passed you out a handout. And this handout, sure, I'll pause for just a little bit. I've passed you out a handout. On the top of this handout, you should write Unit 3, Lesson 5. So on the top of this handout, you should write Unit 3, Lesson 5. Before any of you ask, I'll say there's good news and bad news. I always like to say. Unit 3, Lesson 5. Write that at the top of your handout. Do you want to hear the good news or the bad news first? It's always the bad news. Everybody always wants to hear the bad news first. Welcome back. Next for the bathroom. Clarissa? I'm sorry? You have the paper in front of you. On the top of that paper, write Unit 3, Lesson 5. This is a handout. So the bad news, which has been requested, is that you will have to memorize shapes and bonding. Like, that's going to be part of the unit exam. That you're going to have to be able to, from a Lewis structure, know that something is shaped, for example, bent, and that the bond angle is 104.5. So that's the bad news. The question is, what's the good news? You don't have to memorize all 8 of them. That is the good news. You can cross out these 3 right here, which are the most complicated ones. The shapes of molecules that have 5 and 6 groups are outside of the scope of a high school level curriculum, so you're welcome. I'm not going to test it. However, it would be seen at a college level course. For example, in the AICE course or in a college level chemistry class, you would have to know these additional things. And so you will have to know the shapes of the other types of groups, the names of the shapes and their bond angles. So we're going to go over it. Keep this paper out, this handout. We're going to write some information on it that's going to hopefully help you to understand what's going on. Let's take a look at linear first. The first thing you want to do is identify your central atom. What is the central atom here in the linear molecule? The one on the left, the one on the right, or the one in the middle? What's the central atom? The middle, right? So the central atom is the one in the center. Central atom. What you do is you count the groups of electrons around that central atom. I know the way that it printed was kind of weird, so you're going to want to fill in the lines here to show that these atoms are connected to each other, and we'll do that for each of the examples. Each of the 5 we have to know. So central atom is the one in the middle. So what is being communicated to us here? How many atoms are being connected to that central atom? And we can also say that that's 2 groups of electrons. One that's a covalent bond that way, one that's a covalent bond that way. 2 groups of electrons. 2 sides that have electrons coming out. Does this shape make sense? It's a straight line. I got the name linear because these 3 atoms are all in a straight line from each other. Linear. Next question. What is the bond angle? What is the bond angle? And yes, we're thinking numbers. Between these two atoms that surround the central atom. What do you think it is? If it's a straight line, what is the angle? Correct. It's 180 degrees, right? A straight line would always be 180 degrees. So the angle is 180 degrees. You can get that angle by taking 360, which is the total way around, and dividing by how many atoms you have. You can get this by taking 360 and dividing by 2, and that would also give you 180. That works for any molecule that is two-dimensional, as long as you're working with a flat molecule. So, is a linear molecule two-dimensional? Yes, it's a straight line. So write 2D on the side for you to know there's no third dimension here, it lies flat. So that's the first one. So you have to know if you see one atom in the middle and two atoms around it, and there's only two groups of electrons, it's 180 degrees, and it's a straight line. Like that's the shape of the molecule. Next one, trigonal planar. First thing, how many atoms do you see around the central atom? You should fill in these three lines just to make sure you know they are connected in. They're all connected in with covalent bonds. And so this is three groups. The best way to say it is three groups of electrons. So every time you have three groups of electrons around your central atom, you're going to have something called trigonal planar as your shape. Does that word make sense? Let's break it down. Trigonal. What does tri stand for? 1, 2, 3. Trigonal, right? Tri. Planar, what is that? A plane, but what is that? What is that? It actually means flat. One plane means like the XY plane. It means that it's flat. So that means that this molecule is a flat. It lies flat, and it's got three atoms. Two-dimensional. Another way of saying that is two-dimensional. So write 2D there. All right. Can you predict without additional assistance? What is the bond angle around any two of the atoms in a trigonal planar molecule? Can you predict what that is? What is the bond angle here between those two atoms? How can you figure that out?
60 divided by 5.
You can say 360, right? Divided by the amount of atoms, it's 3. Yeah, you can say something. 360 divided by 3, 120. Trigonal planar's bond angle is always 120. And you will have to memorize that, yes. Yes. Go ahead. You're next. Another reason they call it trigonal, if you connect the ends, like in your head, connect the ends here, and what does that make? A triangle, right? Triangle. Trigonal planar. That's just to give you an idea of why it has that name, because that's the actual shape of the molecule. All right, so for benzene pyramidal, go ahead. You have to fill in additional information to understand what's going on for these two. So first of all, you'll want to connect these. Make sure you connect them. I know that the way that it printed, some of those white lines didn't show up. So, and then fill in a pair of electrons here and a pair of electrons here. For pyramidal, you should see there's 3 connections that you need to fill in, and then there's one unshared pair you need to put at the top. I'm going to talk about these shortly, but first we need to talk about tetrahedra, actually, before we do those two. So just fill in those little pieces of information to help with understanding later on, and then we'll talk about tetrahedra next. We've done 2 groups of electrons, that's always linear. 3 groups of electrons, that's called trigonal planar. And now we're going to talk about tetrahedral, which is how many groups of electrons? Can you see from there? How many groups are around the atom in the middle? 1, 2, 3, 4, right? So 4 groups of electrons. So whenever you have 4 groups of electrons, you're actually going to get a 3-dimensional molecule. So that's the whole point of having to talk about 3D is whenever you have 4 groups of electrons, which many of our molecules do have 4 groups of electrons around them. And so we're going to discuss it. If you have 4 groups of electrons, this actually means that you have a group coming out and you have a group going to the back. But before I talk about the bond angle, does the name make sense with what's going on? The prefix tetra. Have we heard that before? In this unit of studies, we've actually had to already memorize that that meant 4, right? So it means 4 again. 4 groups of electrons. So tetrahedral, 4 groups of electrons, just to help you with the memorization. And then the other thing is, unfortunately, you can't use the trick of taking 360 and dividing by 4 here. Why not? You can only do that trick if you've got something that lies flat, if it's 2-dimensional. But this is actually 3-dimensional. So you unfortunately cannot use a trick to get the bond angle here. Out of all the bond angles, this is the one you absolutely must just memorize. It's 109.5. That is the bond angle between 2 atoms in a tetrahedral molecule. It's a little bit wider than you would think it would be. You would think it would be 90, but because it doesn't exist in 2 dimensions, it exists in an additional dimension that alters the shape a little bit. Yes? No, you're good? So that's tetrahedral. So, let's talk about pyramidal and bent. First of all, how many groups of electrons do you see in the pyramidal? There's 1, 2, 3, but would an unshared pair of electrons also be a group of electrons? Yes. So underneath pyramidal, go ahead and write that that is 4 groups of electrons. 4 groups of electrons. But you've got something new here. One of those groups is not an atom. One of those groups is an unshared pair. Shouldn't that change the shape of the molecule? It can't be tetrahedral. It doesn't have 4 atoms coming out of it. So the name is called pyramidal because the idea is if you took the top off of a tetrahedral and now you have what's left. What is pyramid? What is that? Anybody ever heard of a pyramid before? Think about Egypt, right? Pyramids. Do those have a specific shape? They're bent, like they have a top, and then they're bent with 3 sides down. So that's what you have to imagine here, that the central atom's actually at the top, and then the 3 other atoms are bent down, just like a pyramid. That's why it's called pyramidal. And so the way to view it is that an unshared pair bends the other atoms down. Unshared pairs bend the other atoms down. And in this case, it'll take it from being in a plane, not planar, it's now a trigonal pyramid or pyramidal. Yes? Mm-hmm. Welcome back. All right, so there's something else you need to know. I'm about to give you I'm about to give you the molecule instead of the bathroom pad. All right. The other thing you need to know is the bond angle now. So I'm going to tell you one thing. You should write it in this space, and it'll help you with predicting the bond angles for both pyramidal and bent. If you know this one piece of information, instead of having to memorize 3 bond angles, you'd actually only have to memorize the 109.5 and then use this trick I'm about to teach you. So, turns out that are more repulsive than shared pairs because they're smaller and they're just electrons, whereas with atoms, they're larger. So let's write this down. Unshared pairs repel more than shared pairs. What does that mean? That means that every time you have an unshared pair, you subtract 2.5 degrees from the main group. So I'm going to write that. You're going to write that underneath. So each unshared pair subtracts 2.5 degrees from the main group's bond angle.
Write that on this paper.
You should write it, either one. You have to know it though. Or you just have to memorize the bond angles, your choice. So that's important information. Unshared pairs repel more than shared pairs. Each unshared pair subtracts 2.5 degrees from the main group's bond angle. So, knowing that, and knowing what is said here, can we figure out then what is the bond angle for a pyramidal molecule around the central atom? So what is the angle between two atoms? Can we figure that out? 4 groups of electrons. What number is for 4 groups? It's the one number you just got to straight up memorize. It's 109.5. So 4 groups of electrons would be 109.5, except one unshared pair means you do what now? Take away 2.5 from 109.5. So in order to get the bond angle, you would take 109.5 and subtract 2.5. What does that give you? And it turns out every time for pyramidal, the answer is going to be 107. You can look at the chart underneath. It'll say 107. And so this is a little trick to help you so that you don't have to straight up memorize a ton of values. The last one's bent. Bent. How many groups of electrons do you see in bent around the atom in the middle? How many groups of electrons? There's one here, there's one there, but then there's also that pair at the bottom and the pair at the top. How many total groups of electrons is that? 4. But 2 of them are unshared pairs. So what happens in a bent molecule is if 2 of the atoms in a tetrahedral are instead replaced with electrons, you get this shape. What does this look like? It's bent down, right? The 2 hydrogen atoms are bent down. And so that gives us this shape of bent. It's basically replacing 2 of the atoms with pairs of electrons. And so what is the bond angle around the 2 atoms in a bent molecule? And yes, I saw this in the last class. It looks like good job. What is the bond angle around these 2 atoms? How could we figure that out? It is 104.5. You would take the number for 4 groups that you got to memorize, 109.5, and then knowing every unshared pair, you subtract 2.5. You would do 109.5 minus 2.5 minus 2.5, which is 104.5. So the answer here is 104.5. And all bent molecules have a bond angle between their 2 atoms of 104.5, actually. And so this is actually pretty much the content of the lesson itself, most of the content of the lesson. You are going to have to memorize for each of these 5 types of molecules with these central atoms, what the shapes and what the bond angles are around the central elements. Now, we have a little bit more to go over before I break out the molecular model kits with you. What we still have not yet discussed is what does and doesn't count as an electron group, and how to draw molecules three-dimensionally. For the three-dimensional molecules, how do we show depth in molecules? So we're going to do that now before we get to the activity. I'm pausing to give a little bit of time if anybody else was still writing on here. Yes.
What's the top one?
Which top one?
Top of the deck.
104.5.
Is it the same thing for the bottom?
It's the same thing here. Like this is the math that proves the 104.5. It's just 104.5. Bent is always 104.5. I'm sorry?
On the top.
Which top? 104.5.
Hold on, bro.
Let me see that.
104.5
That's for the whole thing.
for. Oh, do you mean like the other way?
Yeah, the other way.
You don't have to do the longest way.
Oh.
But if you wanted to, nobody will ever ask this. Like, I won't ask it. Cambridge doesn't ask this. But if you wanted to figure it out mathematically, you could do 360 and subtract 104.5, and you would get it. Welcome back. Yes. So whatever 360 minus 104.5 is would be what the top angle is, but you don't have to know that or memorize that or use that for anything. All right, so what do we have to know? Well, if you were paying attention, I've given you hopefully a visual method to figure out most of these so you have less to memorize. If you either weren't paying attention or didn't understand this or hate math, like those are the options, then your other choice is you have to memorize this chart. So I printed that at the bottom. This basically is you count the size of your atom, how many pairs of electrons you have, how many of those are unshared, and then you get the shape and the bond angle. And I have it all printed for you. But I wanted to try to give you a different method and not just tell you to memorize it, but give you a method to try to understand how to get each of the shapes and how to get each of the bond angles. So we have a couple things to address. What counts as a side, and how to draw 3D before we can get to the fun part of today's class. So what counts as a side, or I'd like to rephrase this, what counts as a group? Because I've been using the term group. What counts as an electron group? And so we're going to look at a couple of examples and see if you can figure out what counts as an electron group. When you are figuring out the shape and the bond angle, the first step that has to be done is you're going to have to draw the Lewis structure. Now, to save some time, I'm going to draw the Lewis structure for you, and you just have to interpret it. But when you get to your activity in a little bit, you're going to have to draw the Lewis structure as your first step before you can do anything else. So let's take a look at a couple of examples. This is going to be the first one. Going to be the second one. Okay, we're going to do one at a time. The one on the left. The question is, how many groups of electrons do you see in the molecule on the left? That's this one. How many groups of electrons do you see? Around the central element, how many groups of electrons? The question is, what counts as a group? And so this is where we got to be real careful, because this is where we can make a big mistake. There's a group connecting carbon to oxygen on the left-hand side. And there's a group connecting carbon to oxygen on the right-hand side. There are actually here only two groups of electrons. By looking at the molecule, you can observe, hopefully, that that's not tetrahedral, right? It wouldn't make sense to answer that it was this. Because if you say it's four groups, you might accidentally think, oh, that's tetrahedral. But there's not four atoms connected around the central element. So what I'm trying to get at here is that single bonds, double bonds, and triple bonds all each count as one group. So So we're gonna write that down. So the first thing you've got to know is that single bonds, double bonds, and triple bonds count as one group each. That means if you have a double bond, you only count it as one group, one side of electrons coming out. If you have a triple bond, you only count it as one group, and if you have a single bond, you count it as one group. So we're basically counting the atoms that are around the central element. That was the first example. So now that we know that it's two groups, what is the name of the shape and the bond angle for the molecule on the left? Can we practice with that? What's the shape of this molecule? What do you think? Linear. And the angle around the central element, what do you think? 180. That's also correct. So that's what you have to be able to do. You have to be able to, from a drawn molecule, or you have to draw the molecule and then figure out what is the shape of that molecule and what is the angle around the central element between any of the two atoms. So we're going to do the second one now. The second one. You should draw it in your notes so you know what you're looking at here. NCl3 is our second example. Taking a look at NCl3. How many groups of electrons are around the nitrogen? Because the shape is from just around the center element. So you only count around the element in the center. Or what we call the central element. So how many groups of electrons does that nitrogen have? All together. 1, 2, 3, and then the unshared pair counts as a 4. So there's 4 groups in total. And one of them is an unshared pair. So this tells us that unshared pairs count as groups of electrons. So they count towards your total. Is this enough information to tell you what the name of the shape is and what the bond angle around the chlorine around the nitrogen for the chlorine atoms are? I've got 4 total groups. One of them is an unshared pair. What is the name of this shape? It's a pyramid. Yep. So that means that because of this unshared pair of electrons, it bends these 3 chlorines down. So the nitrogen's at the top and the 3 chlorines are at the bottom. So it gives you the name of the shape. It's called a pyramid. And the bond angle, what's the bond angle for pyramid? It's always going to be the same. What is it?
107.
107. So then that actually kind of brings an issue. Is this fluid structure showing that 107 the way that we've drawn it? So we're going to have to fix it to draw the correct shape later on. I'll show you how to do that in the next slide. Because right now we're not actually showing the correct shape that is shaped like a pyramid. Molecule on the right-hand side. This is the last one we're looking at before we do the next thing. How many groups of electrons are in the molecule in the right? Go ahead. Yeah. So how many groups are around the carbon? How many electron groups? You're welcome. How many do you count? 3. Right? Because the single bonds each count as 1, but the double bonds each also only count as 1, just to be clear. This is 3 groups. Are there any unshared pairs? No. Is this enough information to figure out what is the name of the actual shape? Like, what is the shape of this actual molecule? And what is the bond angle around the atoms? Like, how is it actually organized? Well, what is it? 3 groups is what? Trigonal. And then this means that the actual bond angle is I've got 3 groups around the center and it's a 2-dimensional molecule, 120. And so this is the types of decisions you're going to have to make. Now, have I drawn this Lewis structure with the correct bond angles? Is this the way that it's actually shaped? This is showing these 2 hydrogens are 180, and this oxygen and hydrogen are 90. That's not right. So could we fix? Would that be hard to fix? To show the actual shape, I'm just going to show this one here because it's 2-dimensional. You could just fix it like this. Draw one at the top, draw one atom like this, kind of like to angle it like a triangle. Now, am I going to get like a protractor out and see that you got exactly 120? Nope. Estimate 120. So what looks like they're as far apart from each other as possible. As long as you angled it like that, it's fine. So this shows the shape properly. The trigonal, like how it's actually organized, how far these atoms are from each other. All right, so that's the first thing we had to address. The second, and I'll pause for a little while, 20 seconds to give you some time. Yeah. The second thing we have to address is, what if I have something that's not 2-dimensional? What if it's 3-dimensional? How do you, in a drawing, show depth? How do we draw 3-dimensional molecules on a 2-dimensional paper? The artists in the room have to draw 3 dimensions, I think, a lot. Probably way better than I ever would. Terrible artist. So in chemistry, we just have like a simple method of just showing depth, which I'm going to tell you now. All right, so only when you have 4 groups of electrons, and specifically only for tetrahedral and for pyramidal, will you have to show depth, because those are the only 2 3-dimensional molecules that types of molecules we're going to be working with. So how do we draw 3D shapes for 4 groups of electrons? This is the last new thing you need to learn. Then we're going to take a look at a couple examples, then I'll talk about your activity. So 4 groups of electrons. Before I show you, I'm going to say that I'm going to use the letter X for the central element. And I'm going to use the letter Z to represent any random outer element. Anybody want to wonder why I skipped Y? Why do I do X and Y? Why do I do X and Z? I'm going to say a random element X is my central element, random element Z is my outer element. Why did I skip Y? Why did I skip Y? Is there an X on the periodic table that you could be confused by? No. Is there a Z, like a straight up Z on the periodic table? Is there a straight up Y on the periodic table? So if I use Y for an atom, you could totally confuse it that I'm giving you yttrium if you were like looking into it. So that's the reason why I'm choosing these letters. So the idea is that I'm going to represent X for my central element and Z like for my random outer element. You have to know how to draw tetrahedral and pyramidal molecules in 3 dimensions. So I'm going to teach you each one. In order to show depth in chemistry, and it is in the tutorial, if you want to go back and look at it in the tutorial later on, you can feel free to. This information is there. But in order to show depth, if an atom is going towards you, you use a wedge. So wedges, and I'm going to write it here. This is called a wedge, which is basically a shaded-in triangle. We call this a wedge. And this is used for atoms coming towards you, meaning to show the depth that it's coming out at you. Basically, we show a wedge to say that that atom's actually going towards you. It's not flat, it's actually moving towards you. And then we use dashes like this to represent, so we call these dashes, and this represents any atom that's going away from you. So facing to the back. So going away from you, so like if I'm looking at this one, this is facing towards me, away from you. So if it's going away from you, you use a dashed line. So for tetrahedral, this is what you're going to need to remember. X would be your central element. Then you have, I was on the right line. Z. A Z here. And then in a tetrahedral molecule, there's always one atom coming towards you and one atom going away from you. And you're going to see this when you're making the models very soon. So you're going to show a wedge for one and dashes for the other. This is tetrahedral. That's how you actually show the 109.5 angles between the molecules. It's not 90, it's 109.5. The good news, if you remember tetrahedral, pyramidal is actually very similar. You just take the top part off. So like that top Z atom, you basically just take it off. Take the top part off, replace it with a pair of electrons, and that's pyramidal. So now it would be X. Instead of the Z on the top, you do a pair of electrons. And then everything else is organized exactly the same. So you get this, you get this, you get this. And this is supposed to be interpreted as you're supposed to understand this Z is going down straight that way. This Z is going down, but at you, like a pyramid. And then this atom is going to the back and down. That's how you're supposed to understand it. So this atom's on top, this is face down like that, that's face down like that, and it's face down the other ground. And that's called pyramidal. And the bond angle between any of these two atoms would be 107. Just to remember. All right, so before we do the activity, I told you I wanted to do just a couple practice questions so you could see what's going to be expected of you. What type of questions are you going to be asked out of this lesson? So I'll give you a little bit more time here, and then we're going to take a look at a couple examples. Welcome back. Just take a picture real quick. Thankfully, we're about to get to the activity. All right, Kehlani, did you get the picture? No. Okay, let's at least take a look at an exam so you can see what types of questions you would be asked here. Critical shape, fix the bond angle for each of the following. And so you have been given a molecule, CCl4. You are being asked for what is the shape. You are being asked for what is the bond angle. And I'm also asking you what is the three-dimensional model. So that means draw it with the correct dimensions where you show the bond angle. CCl4. How would you know what the shape is? What do you think the first step should be before you do anything? What should you do? And this is also for the activity today. First step is going to be to draw the, what do we draw? Lewis structure. And that's going to be the first step in most of the rest of this unit for anything else that we learned. The first step is pretty much going to be draw the Lewis structure. Draw the Lewis structure. Well, can we draw that for CCl4? I hope so. It's going to be on the quiz next class, right? So first step of drawing a Lewis structure is, just to review, what goes in the middle? Carbon. How many chlorines are there here? 4. So you draw the 4 chlorines around on 4 sides. 1, 2, 3, and 4. What's step 2 in drawing a Lewis structure? What do you got to do next? Valence electrons. Carbon has 4. Chlorine has 7. And on the quiz, if you do not write all of the correct amount of valence electrons, would it be counted as a correct answer? even if you're missing one electron, it will be wrong. You have to get all of your valence electrons correct, or else you have made something that's not stable. Doesn't exist. So you have to be careful. Carbon gets 4, chlorine gets 7. Now what do we do? What's step 3 of drawing a Lewis structure? Your singles, you gotta mingle your singles. So all your single electrons, you pair them up. You make your covalent bonds. This is a level 1 question because it just automatically works out. Remember, the quiz next class is just level 1 and level 2 questions for the 100%. But if you want 120, you got to do the more complicated ones. Are we good so far? Now that we've done the Lewis structure, can you figure out the shape? What would you do? Count the groups. How many groups are around carbon? 4 groups, right? So if I've got 4 groups, but none of them are unshared pairs, what's the name of the shape? 4 stands for tetra. So tetrahedral. And that's the one bond angle. You just got to straight up memorize it. 109.5. And then the 3D model. How would we write this to show the correct angles? Because the Lewis structure does not show the correct angle. So how do we fix it? Now we gotta, basically this gets a wedge and this gets a dash, and you bend this chlorine down a little bit. So for the 3D model, it's gonna look like this. C, because you gotta use the actual atom. C, Cl, and Cl here. A little bit bent down because it's got to have a larger bond angle than 90. Use a wedge for the bottom. That shows that one chlorine's coming out of the page towards you. And then use a dashed line for the other one. And that's how you convert it into the 3D model. Wedge for one, dash for another. It's basically following that template for tetrahedral right there. So this is what you're going to be asked. For any molecule, simple molecule with one central atom, 2 or 3 or 4 electron groups, you could be asked for the shape, you could be asked for the bond angle, and you could be asked to draw the 3D model. So, with that being said, let's talk about your group activity today so that we have enough time for you to do it. So, to finish up writing this last question, we're going to talk about your group activity, and then we'll get started with that. Don't move to the tables in the back until I have finished explaining what it is you need to do and passing the paper to you.